All right, we're going to look at graphing transformations today. And what we're going to do, we're just going to run through 4 examples where you're graphing a transformed graph and its parent function. So here's example 1. It says graph the transformed graph and its parent function, and it's y equals x minus 5 quantity squared plus 1. So here the parent function, let me grab my pen. The parent function is y equals x squared in this case. So let's make a table for this. Let's do a little xy table. And we'll start at -2, we'll go -1, 0, 1, and 2. There we go. And then we'll plug these values in for x and we'll get our y. So -2 squared is positive 4. 1 squared is 1. 0 squared is 0. I said 1 squared. -1 squared is positive 1. 1 squared is 1. And 2 squared is 4. So let's graph this parent function. We'll do this in black. So -2, positive 4, -1, 1, 0, 0, 1, 1, and 2, 4. And so it's going to look something like this. Ooh, that looks terrible. Let's fix that. Okay, let's try that again. Much better. Okay, so there's the one side of the parabola. Here's the other side of the parabola, which is less pretty than the right side, but we'll go with it. So there's our y equals x squared graph. And now we want to graph this other one, and that's in purple, so I'll change my thing. Oh, I thought I had a purple. We'll just do blue. It's closest to purple. And there's a couple ways I could do it. One way is I could make a table, so we'll do that. And what I'm going to do, instead of doing -2, -1, 0, 1, and 2, I'm going to take those numbers and I'm going to subtract 5. Or I'm sorry, add 5. So I want my middle number to be 5. And then I'm going to do 4, 3, 6, and 7. The reason why is I want to see the vertex of that parabola. And I know if I put 0, or if I put 5 in for x, 5 minus 5 is 0. So that's why I chose 5 to be my middle value, and then I just did 2 above and 2 below that. So let's plug these values in. 3 minus 5 is -2. -2 squared is positive 4. And 4 plus 1 is 5. Let's put 4 in. 4 minus 5 is -1. -1 squared is positive 1. 1 plus 1 is 2. We put 5 in. 5 minus 5 is 0. 0 squared is 0. 0 plus 1 is 1. And if we put 6 in, 6 minus 5 is 1. 1 squared is 1. 1 plus 1 is 2. And we put 7 in. 7 minus 5 is 2. 2 squared is 4. 4 plus 1 is 5. So it's nice and symmetric, just like the other one. So we go 3, 5 over 3 up 5. 1, 2, 3, 4, 5. 4, 2. 5, 1. 6, 2. And 7, 5. So it looks something like this. Okay, so one way is to make a table. Another way is to just look at the vertex. I know the vertex, it's going to be over 5 up 1. And that's what we see here. It's over to the right 5 up 1. And then if you see, we went over 1 up 1. We went over 2 up 4. Then we went, you'd go over 3 up 9. So you can just kind of take this parabola and redraw it over 5 up 1 if you want to do that. And then one thing I do want you to notice is if you look at, we'll do this in red so it stands out a little bit. If you look at these x values and then the other x values I picked, every single x value is added by 5. And I see that from the equation here. So if it's x minus 5, I'm going to add 5 to all the x values. If this was x plus 5, then I would start at -7, go to -6, -5, and so on. So I want to make this value 0. That's going to be my middle number. And then all the y values, let's look at those. We'll circle those in green. All of those are our parent function, but we add 1, and that's from going up 1. Just something to notice for a little bit later. Okay, let's look at example 2. Same instructions, graph the parent function and the transformed graph. Uh, so the parent function this time is once again y equals x squared. We'll go parent function is y equals x squared. And we'll write our little table again. Okay, and then we just plug it in. We got 4, 1, 0, 1, 4. These are just the numbers I took from the previous problem. It's the exact same parent function. So let's graph this parabola. It's going to look something like so. Ooh, that got off. Let's fix that. I got cocky. Okay, and then there's the left side. For some reason, I can draw the right side well. So this one, I know the negative is going to flip it upside down and the 2 is going to stretch it out. But let's do a table just to see kind of what happens. So we'll do x and y. And I'm going to do the same x values. So -2, -1, 0, 1, and 2. And then I'm just going to plug those in. -2 squared is 4. 4 times -2 is -8. -1 squared is 1. 1 times -2 is -2. 0 squared is 0. 0 times -2 is 0. 1 squared is 1. 1 times -2 is -2. And 2 squared is 4. 4 times -2 is -8. So let's graph this new function. It's going to be -2, -8. It's going to be -1, -2. It's going to be 0, 0. 1, -2. And 2, -8. So we've got our table set up. We can just graph this beautiful function. And so what happens here is the x's don't change, but the y's do. And all of these values are, all of the values in this right side of the table here are multiplied by -2. Another way you can look at it is I'm going to take this parent function, I'm going to flip it upside down, and instead of going over 1, up 1, since it's a factor of 2 on the outside, we're going to go over 1, down 2, and it's down because it's negative. So instead of over 1, up 1, it's over 1, down 2, and then instead of over 2, up 4, it's over 2, down 8. It's just doubling the difference between each point, I guess. Okay, let's look at a new one. Now we're going to look at a different parent function. We're done with parabolas for here. This is y equals negative absolute value of 1/4 x. So let's make a table and identify the parent function. So the parent function on this one is y equals absolute value of x. And so our table will do x and y again. And we'll start with the same values, -2, -1, 0, 1, and 2. And my goal whenever I want to graph absolute value, I know it's going to look like a V. I want to make sure whenever I graph it, I see that V. If I don't have values on the left and right, it's just going to look like it's a straight line. Okay, so if we plug -2 in for x, the absolute value of -2 is +2. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. Let's graph these points. Got 1, 1, 2, 2. We'd have 3, 3, 4, 4, and so on. Then we got -1, 1, -2, 2, -3, 3, and so on. So it's two nice straight lines with a slope of 1, one with a slope of 1, one with a slope of -1. Okay, there's our absolute value graph. Now we're going to graph the absolute value of -1/4 x. So the negative is going to flip it upside down, and the 1/4 is going to horizontally compress it. Now we'll see. Let's see what happens with the table. So x, y, and we can use our same values. We're going to end up with some decimals here, but that's okay. We'll do -2, -1, 0, 1, and 2. And if we put these values in for x here, we're going to get, let's see, it'd be -1/2, but the absolute value is 1/2. Then we make that negative, we get -1/2. We put -1 in, we get -1/4. Absolute value is +1/4. Make that negative, so we get -1/4. Put 0 in, we get 0. Put 1 in, we get -1/4. And we put 2 in, and we get -1/2. Now this is going to be kind of ugly. I want to show you a better choice for x's instead. But we'll graph it nonetheless. We got 0, 0. We've got -1, -1/4. We have -2, -1/2. We have 1, -1/4, and 2, -1/2. So it's going to be something like this, and something like this. So this is a horizontal stretch by a factor of 4. So when we do that, what we should have done instead, I don't really like these values for my table. To make it a little bit cleaner, ooh, I didn't need one that quite that long, is I'm going to pick different values for x. And what I'm going to do is I'm going to multiply all these numbers by 4 so that we get nice whole numbers instead. So this is going to be -8. And -8 times 1/4 is -2. Absolute value, that's 2. And then make that negative, you get -2. Then we'll put -4 in. This would give us -1. If we put 0 in, it's still 0. If we put 4 in, we get 1. And if we put 8 in, we get -2. Oops, this is -1 here, sorry. So you'd get the same graph. It's the exact same graph. You're just dealing with more whole numbers. So, but the moral is if you have a value inside, then you take the x values and you multiply by the reciprocal. So instead of -2, we multiply that by 4 and we get -8. Okay? And then the y values were affected by this negative sign. Those all became the opposite. Okay, last example. We have y equals -1/3 square root of -x. So we have 3 different transformations going on here. Let's identify the parent function. So the parent function is y equals the square root of x, is what I meant to say. And so we'll make a little table. And then we don't want to use -2, -1, 0, 1, 2, because if we do the square root of negatives, we get imaginary numbers. So let's start with 0. Let's go to 1, and then I'm going to do 4 and 9, just to get some nice whole numbers here. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and square root of 9 is 3. Let's graph this. We got 0, 0, 1, 1, 4, 2, and 9, 3. So it's going to look something like this. It's going to look kind of like it's half of a sideways parabola. Okay, and then to get our table for the next one, I'm going to pick the same x values, except that's going to make all these negative. So maybe that's not the best idea, right? If we put 1 in, we get square root of -1. That's not going to work. So since this is negative, I'm going to make all these the opposite. So we'll do 0, -1, -4, and -9. And then the y values, we'll just plug these in and see what we get. So we get square root of 0, 0. 0 times -1/3 is 0. So it's going to start at the same spot. If we put -1 in, -1 is +1. The square root of +1 is 1. 1 times -1/3 is -1/3. Let's put 4 in. -4 is 4. Square root of 4 is 2. 2 times -1/3 is -2/3. And we put 9 in, or -9. -9 is +9. Square root of 9 is 3. 3 times -1/3 is -1. So our new function is going to start at 0, 0. It's going to go -1, -1/3, -4, -2/3, -9, -1, and it's going to look something like this. Now, what I want to do, because I don't think this is going to be a straight line, is let's just do one more. Let's do -16 and see what happens there. Oh, shoot. I'm sorry. I didn't graph these correctly. Looks like a straight line because I did it wrong. Let's go back and graph this. Sorry about that. So we've got -1, -1/3, and then we go to -4, -2/3, and then we go to -9, -1. There we go. That looks more like it. So it's going to go something like this. Oop. Let's try over. So what this one did was it flipped it upside down. So it flipped it over the x-axis, flipped it over the y-axis, and this 1/3 pushed it down. It was a vertical compression by a factor of 1/3, so it made it a lot skinnier. Okay, and those are our 4 examples of graphing transformations.